Okay, so now we're looking at 2.3 factoring polynomials part 1. We're actually going to be doing the opposite of what we were doing in 2.2. So in 2.2 it was a lot of distributing or multiplying polynomials together. Now we're going to do the opposite. So what we're going to do here is factoring polynomials is just like the distributive property backwards. So we're going to be going in reverse, and it is a little bit more challenging. So don't get discouraged if you're a little confused at first. It's going to take practice. Okay. So when factoring a polynomial, the first step is to find the greatest common factor between the terms. And what that, to kind of make that a little bit easier to understand, you're basically looking for what does all the term, what would divide evenly into all the terms. So if you look at 5a plus 35, what divides evenly into 5 and 35? That would be 5. That would be the greatest common factor, which basically means multiple, greatest common multiple. And so the greatest common factor is 5. So once you have the GCF gets taken out. It gets divided out. That's why I say, look what would divide evenly into those values. Okay, so we're going to divide that out of the expression from the factors that are left stay in the parentheses. So what we're going to do here is we have 5a plus 35. We're going to divide both of those by 5, and we put that on the outside, and then we look at what's left in the parentheses. So when you divide by 5 with the 5a, you're just left with a. And when you divide 35 by 5, you're left with a 7, or plus 7 right there, right? And that's our answer right there. This is our answer. And you can always check it by redistributing. So if you were to go ahead and multiply it back in, 5 times a, 5a, 5 times 7, 35. And so you can always check it. So we're doing the opposite of distributive. So you can see right there, if you want to, just distribute it back in to check yourself. An important note is that when the leading coefficient is negative, you want to factor out the negative as part of the GCF. So let's go back up to this example we just did right here. So if I had, let's say it was negative 5a plus 35. Let's say that was the problem instead. What you would do is you'd have to factor out not just 5, but pull out a negative 5, okay? And so when you do that, that's going to cause a sign change. When you divide both of these by negative 5, this would become positive a, and this would actually become a minus 7. Okay, so just to kind of give you an example of what this note is referring to right there. So if the leading coefficient, if the first term is negative, make sure you pull that negative out with it. That'll make a little bit more sense why we do that later on when we start applying the concept. So don't worry about it too much right now. Just recognize if you see that, go ahead and factor that negative out in front. Okay. So let's go ahead and get started. And so once again, like I kind of have been doing for most videos, I show a lot of detail on the first few examples. And then as you get more comfortable, you can kind of take a couple shortcuts if you feel comfortable with that. But at first, I don't want to skip anything and confuse anybody. It's already going to be challenging enough. So let's look at our first one. So we have 18x plus 27. So you're trying to figure out what is the greatest common factor. Well, if you're looking at this, if you really want to break this down into detail, what you would do is you break the numbers up into primes. So let's see, 18 can break up to 2 times 9, but then the 9 could break up into 3 times 3, right? So I just broke up that 18x into 2 times 3 times 3 times x. And if you multiply that together, it would go right back to 18, right? And then if I look at 27, 27 could break up into 3 times 9, right? 3 times 9 is 27. But then that 9 could break up into 3 times 3, right? So I broke everything into prime factors. So prime numbers are numbers that are only divisible by itself or by the number 1. Then what we do is you look at what they have in common. Let's look and see what they have in common. And so they each have 2 3s. There's 2 3s here and there's 2 3s here. It doesn't matter which 2 I grab. And what we're going to do is we're going to factor that on the outside. I'm going to take those 2 3s to the outside, and then what's left behind is a 2x on the first term, and then a plus. There was still a 3 left back here, so we'll leave that right there. Now, that 3 times 3 on the outside, we'll go ahead and multiply that together, and that'll be 9 times 2x plus 3. And that is my answer. That is my answer. So, and if I were to distribute it back in, you would see it would go right back up to 18x plus 27. Now, do I expect you to do all the problems like this? No, but if you need to, go ahead and do that. But the numbers aren't going to get too crazy. They should never, I don't think any of them will go to triple digits. So a lot of these, you'll probably, as you get comfortable with it, you could probably do this in your head, and you could probably do this in one step. You look at 18 and 27. Oh, those are both divisible by 9. Pull out the 9, divide all the terms by 9, and there you go. But it's going to depend on your comfort level, okay? So on this next one, I'm still going to kind of take a pretty detailed approach. So on the first term right here, it's just 2 times y. I can't break up the 2. And then we've got a minus 6xy. So minus the 6, I can break up into a 2 times 3. And then I have an x and I have a y, right? And so when I look at this, what do these terms have in common? So the terms are separated by addition or subtraction, right? So if I notice, this one has a 2 and a y, and this one actually has a 2 and a y also. They both have a 2y. So I'm actually going to factor out 2y from both of them. So you might be like, well, I'm taking the 2y. I guess there's nothing there. Not quite, okay? So think about this. If you were to divide 2y by 2y, 2y divided by 2y would actually give you a 1, right? Anything divided by itself is a 1. Another way to look at this is you could just go ahead and look at this as having a times 1 right there. Okay, you could have a times 1, because that wouldn't really change anything. 1 times 2 times y is still 2y. So I'm taking out the 2y, but there's going to be a 1 left there from my first term inside the parentheses, okay? So be careful about that. And then on the back part of it, I'm taking out the 2 and the y. I still have my minus there. The only time there'll ever be a sign change is if you factor out a negative. So other than that, everything should stay the same. And then let's see, I'm left with a 3x, and that is my answer. And once again, if this is something you haven't done in a long time, or maybe you've never done it, the best thing for you to get better at this is to multiply it back together and check your answer. 2y times 1 is, well, 2y, good. 2y times a minus 3x, well, 2 times 3, that'll give me my minus 6, and then I'll have an x and a y, okay? So it's, don't get too frustrated. This is something that will take some time if you've never done it before. And I guess I should say this now also, factoring will be probably the most important thing that you're going to learn to prepare for college algebra, which we're starting in less than 30 days. So we got to, the rest of the developmental unit, honestly, is going to be mostly focused on factoring, and this is the beginning of it. Okay, looking at number 3, so let's see, I've got 3x squared plus 6x. So that x squared, I can actually, if I want to, I could write it as xx, right? I could break it apart as x times x, same thing. And then I have a plus, and then that 6x I'll break up as 3 times 2 times x. Okay, so between the two of them, they both have a 3, they both have an x, both have a 3x right there. So I go ahead and take out the 3x, and that will leave me with an x here, and a plus, that second term has a 2. And there we go. That's my answer. And once again, you could multiply it back in there, and you would see that you'd go right back to where we were. And so that's a good way to double check yourself. All right, so our next one, you'll notice I have a negative leading coefficient, okay? So I am going to have to pull out a negative when I do my GCF. And so that's going to cause a sign change for both of them, okay? And so let's go ahead and take a look at this. So let's see, I'm going to break this up. Well, yeah, let's go ahead and break this up. So let's see, I can break 8 up into like a negative 2 times 4, and then the 4 can be broken up into 2 times 2, right? So if I multiply all 3 of those together, that would give me negative 8. Then I got times a and then times x. And then the minus 48a squared, let's see, so minus, and then let's see, 48 can break up into 2 times 24. And then, here, let me write this down because this number is a little bit bigger. So what you can do, by the way, and I'll just erase this. I'll do it over here on the side so I have some space. So like you have 48. What you can do is do a little factor tree right here. 2 times 24. And then that'd be 2 times 12. And then that would be 2 times 6. And then you can break the 6. Let me get myself a little more room. And then we could break that up into 2 times 3. And I'll go ahead and erase that in a moment. But let's see. So I have 1, 2, 3, 4 2's. So let's see, 2 times 2 times 2 times 2. And then I have a times 3. And then don't forget about the a's. So a times a. Okay, so if the number is a little large, you can do a factor tree. And so let's see, I am going to, what I have to do here is I'm going to factor out 3 2's, and I'm going to factor out 3 2's here. And then I'm going to factor out an A and an A. Now what's going to be a little tricky here is I need to factor out a negative with that, okay? So what I'm going to do real quick, I'm going to clean this up a little bit so maybe we have a little better understanding of this. So this right here would be a negative 8 times a times x, which actually is originally what it was. And then I'm going to have a minus, and I'm going to put an 8 here for 2 times 2 times 2. Then I'm going to have a 2 times 2 times 3, and then my a's, right? Then I have my a's right there. So just so what I did was I'm going to factor out the 3 2's anyways, but I went ahead with 2 times 2 times 2. It's just 8. So now I'm going to go ahead and factor out the 8's, and I'm going to factor out an a with it. Now when I factor this out, I'm going to bring out a negative 8. So that's going to cause a sign change. So that's going to leave me with a positive x right here. And that's going to cause a sign change with the minus. That will become a plus. Okay, I'm taking a negative with it. I'm dividing this by a negative, pulling it out. So it changes the sign here to a plus. Then that leaves me with 2 times 3, which is 6, right? 2 times 3 is 6. I'm factoring out this a, but I had 2 of them, so one of them's still there. And there we go. That's my final answer. That one's tricky. I don't have a lot of those with the leading coefficient negative. Okay, but just, be careful there. That one's tough. You can see if I redistribute it, I'd go right back to where I was when I started the problem. So like I said, that's going to probably be one of the more helpful things is to redistribute it just to check yourself, especially if this is new to you. Now I got to erase my factor tree, so I got room over here. Okay, this next one, there's 3 terms. So you have to find the GCF for all 3 of them, okay? Now I kept breaking them up into primes, and if you want to keep doing that, keep doing that. But what I typically do is I just kind of underline it and I look at this. I'm like, okay, what divides into all those evenly? 9, 18, and 27. Well, they're all divisible by 9. Okay. Now look at their variables. What do they have in common there? And people get hung up on the term greatest common factor, and so they always want to say, oh, it must be x to the 4th power. That's the greatest one. Yeah, that's the greatest, but you're looking for the greatest one they have in common, right? The greatest one they have in common. And so let me make a little room here so you can see this. So see, x to the 4th, you could actually write that as x squared. And then x cubed, you could actually write that as x squared x, right? And then here you have your x squared. So the greatest amount they have in common would be an x squared, right? So that's what I'm going to factor out of this is 9x squared. So let's go ahead and do that. So 9x squared. Now what you want to do is look at each one individually and literally just divide it. 9 divided by 9 would be a 1. If you want to put a 1, you can. It's fine. And then let's see, x to the 4th divided by x squared. Remember that rule? You're supposed to subtract. So that would go down to an x squared, right? And then 18 divided by 9 is 2. Now it's a minus. It'll stay minus. The only way that will change is if your GCF is negative. Then x to the 3rd divided by x squared. You subtract, so that would just become an x. Okay, and then on the last one, 27 divided by 9, that will become a plus 3, and then the x squares would cancel each other out. They would basically become x to the 0 power, which then that would become a 1, and then 1 times 3, it would just be a 3, right? So even if you put x to the 0 power right there, that would turn into a 1, so you'd have 3 times 1, which is 3 right there. And so that is our answer right there. That is it right there. Okay, that's about as bad as it will get. Don't get me wrong, it can get worse, but for what we need for our course, probably that'll be about as bad as you can expect to see. Okay, this next part is still the same. The concept's the same, but a lot of times this is referred to as factor by grouping. Now, what's already been done for us is the grouping part, and we'll see some where they haven't been in just a moment. But what I want you to notice here is that both of these terms separated by the addition in the middle, they both have the x plus 5, right? In parentheses, they both have that. So this is really no different if I had, let's say, for example, xy plus 3y. Well, what do they have in common? They have the y in common. I'd factor out the y, and I'd be left with x plus 3, right? That's what they have in common. They both have the y. Factor it out. I'm left with x plus 3 inside the parentheses. Well, that's not really any different here. What they both have in common is the x plus 5, so I factor that out, and then what's left behind is the x plus 3, So I took this, and I'm factoring it, I'm pulling it out, okay? And then now I'm left inside with just the x plus 3, and that's where the second term comes from, okay? So I've got another one. It's identical to the one we just did. It's the same idea. So I have x squared times x minus 3 minus 12 times x minus 3. So I'm going to take that x minus 3 and we're going to factor that. We're going to pull that common factor out. So x minus 3, and then what's left behind creates my other factor, x squared minus 12. And there we go. That's the answer. Okay, let's see. All right, I got a couple more for you here. So factor each polynomial by grouping. Okay, so it's exactly what we kind of just got done doing, except you actually have to do the grouping process on these, okay? And so the way that works, you notice there's 4 terms. Whenever there's 4 terms, you always want to assume that it's factored by grouping, okay? It won't always work out that way, but many times it will, okay? So right here, what I'm going to do is I underline the first 2 and I underline the second 2. That's basically me grouping them. I put them in groups of 2. So on my first group, I look and see what is the GCF. What can I factor out between the 2 of them? And they don't have a number. They have a variable in common. They both have x's. And this one's x cubed and this one's x squared. And so I'm going to factor out the x squared right here. So I'm going to divide both of them by x squared. That will reduce the cube down to just an x, and then this will become a minus 2 right there, and then the x squared got factored out, so it's no longer there. So if you want to check it, you could multiply this back together, x squared times x minus 2, and it would actually go right back to what we have above. Okay, we don't want to do that, but that's how you could check it real quick. So that I did that part. Now I'm going to do the same thing on the second one. Now the first one kind of gives me a hint. I kind of have an idea of what I'm shooting for over here because I need to have an x minus 2 also. I want to have an x minus 2. And so what I'm going to do is I'm going to factor out a 5 here. So I'm going to pull out a 5. So I divide both of these by 5. So that would just leave me with an x minus 2, right? Divide both of those by 5. That would leave me with an x minus 2. Look, they're both x minus 2. Great. Now it's exactly like the previous page that we were working on. So now I'm going to factor out that x minus 2. So x minus 2 here, and then what's left behind is the x squared plus 5. So x squared plus 5. Oops. Okay, there we are. All right. So our next one looks to be, honestly, it's pretty identical to the one we just completed. So underline the first 2, underline the second 2. Okay, what can I factor out of that first 2? Once again, it's going to be an x squared. And so that will reduce the power of 3 down to a power of 1. And then this x squared has an understood 1 in front. So be careful. You're taking out the x squared out in front as multiplication, and you still have that minus 1 inside there. And once again, if you were to distribute it, hopefully you're seeing the pattern that, yeah, it's the same thing I have right above it, okay? Now, once again, this kind of gives me a hint of what I'm looking for over here on my second one. So on this second one, we're going to factor out a 2. So we'll pull out a 2, and let's see. So divide both of those by 2. That would leave me with an x minus 1. Bingo. I need them to match. They match. I'm good to go. So now we'll go ahead and factor out that, the x minus 1. And then the leftovers would be the x squared plus 2, the values in front that were factored out. All right, clean that up a little bit. Okay, we'll do one more, and then I'll make a second video for part 2 of this. So let's see. This one, once again, looks pretty similar. The leading term that I factor out is going to be x squared once again, just like the previous two. So I'm going to take out an x squared, and that will leave me with 3x minus 2, right? And if you were to multiply it back in, you'd go right back to where you are. Now, this one's a little tricky. What makes this one tricky is I have plus here. I have minus 6x plus 4, but I'm going to need that to be a minus 2, right? I really need 3x minus 2, right? But notice the difference. I have a minus here, and I have a plus here. So that means that I'm going to have to factor out a negative with this. So I'm going to have to pull out a negative, and it's going to be a negative 2. And so when I pull out a negative 2, it's going to cause a sign change for both of these, okay? So that minus 6x turns into a positive 3x, and that plus 4 turns into a minus 2. And once again, you could check it. If you were to multiply a minus 2 by both of these, you'd get a minus 6x, and you would get a plus 4, right? So hopefully you're seeing that connection. And so then from here, we'll factor out that common factor, 3x minus 2. So 3x minus 2. And then the leftovers are going to be our x squared minus 2. Okay? All right. So I know that was a lot, okay? So if you feel a little overwhelmed, that's okay. What you need to do is give yourself a break and then come back and, try, work on it some. Take a break, work on it, don't kill yourself, walk away for a while, come back and work.